In this video, we're going to talk about the different ways in which we describe and classify matter on a very, very general level. So we're going to focus on the difference between pure substances and mixtures, further classify the pure substances a little bit based on their composition, and then compare and contrast homogeneous and heterogeneous mixtures. While you won't often think about these distinctions between different types of matter, really explicitly as you advance in your studies of chemistry, the distinctions are really important. For example, there's a huge difference between homogeneous and heterogeneous mixtures, and I won't speak for the entirety of chemists, but I think as a general rule, chemists like homogeneous mixtures more than heterogeneous mixtures, since homogeneous mixtures are much more conceptually simple, much easier to deal with. So these distinctions do matter, and recognizing these distinctions can be very important in certain contexts. But let's start with a very basic question here. What is matter? Matter is anything that has mass and takes up space. Classic grade school definition of matter here. That doesn't tell us a ton. That is the vast majority of things that we see around us in everyday life. And we can classify matter to get a better idea of what we're looking at, a little more detailed idea of what exactly it is we're looking at. We can classify matter according to its state. Is it solid, liquid, or gas, for example? Also, the composition. What kind of substances compose it and in what amounts? Is it a mixture? Is it just one type of substance? What types of atoms? What types of molecules? That kind of thing. When it comes to composition, the broadest distinction we make is between pure substances and mixtures. Pure substances contain only a single type of atom, molecule, or formula unit. They're defined by a single atom, molecule, or formula unit that really defines the substance. A single chemical formula is another way you can think about this. Mixtures contain two or more pure substances in variable proportions, essentially. And within each of these general classifications, pure substances versus mixtures, we have a further breakdown here. Elements are pure substances that cannot be broken down into simpler substances. And in a module or two, just in a few videos, we'll find out that elements are composed of a single type of atom. This is why they can't be chemically broken down into simpler substances. Compounds can be broken down into elements, and compounds contain two or more elements in fixed and definite proportions that define the compound. We'll come back to this in a future video. But there's a specific proportion of the elements that shows up in a given compound. Mixtures are broken up into heterogeneous and homogeneous mixtures, and you may have heard these terms before. Homogeneous mixtures are also known as solutions, and they're the same everywhere. If you look at them visibly, macroscopically, they look the same everywhere in the mixture. We don't have, for example, solid clumps in a liquid or two solids mixed up in such a way that we can visually distinguish between the two solids that are mixed. Homogeneous mixtures have the same composition at every point. They're uniform throughout. This is where the idea of homogeneous comes from. Heterogeneous mixtures do have different compositions at different points in the substance, so we can actually see or measure distinct phases within a heterogeneous mixture. This slide is just a visual representation of the classifications we've done so far, with matter encompassing everything down below. Matter is either a pure substance or a mixture. Within the pure substances, we have elements and compounds, and within mixtures, we have heterogeneous mixtures, two distinct phases. You can see that here. We have, for example, maybe a solid down at the bottom and a liquid over top. Homogeneous mixtures have the same composition everywhere. So here, notice we have the two types of molecules or atoms in this substance uniformly distributed. This is the hallmark of a homogeneous mixture or solution. To get to some practice with this, I wanted to take a look at some images from an organic synthesis procedure and think about how we would classify each of these substances just based on visual inspection. Now, to back up a slide just for a second, of course, if we think about this carefully and think about our sort of atomistic viewpoint of the world that tends to prevail, we'll realize that everything is mixtures, really. If you get down to the level of atoms and molecules, nothing is entirely pure. But we can take steps, and we do take steps in the chemistry lab to try to purify substances as much as possible to get as close to this ideal of a pure substance as we can, so that the chemical analysis is then simple. It's much simpler to analyze a pure substance than it is a mixture. Just wanted to preface this exercise with that sort of caveat, since we're going to make some approximations in how we think about these substances. So let's start with this first image here on the left. We've got something that looks like a liquid in a round bottom flask, but it's a translucent liquid, and it looks like there's some kind of powder floating in here, right? Some kind of orange powder floating in there. So there's a liquid phase, but dispersed throughout that liquid phase are tiny grains of solid that we can recognize, giving the translucent appearance, making this a heterogeneous mixture. The little solid grains that give rise to the translucence make this a heterogeneous mixture. At least by visual inspection, we would guess this based on the translucent appearance. In the middle here, we have some solid powder sitting in the bottom of a vial, and it all looks exactly the same. So this is either a mixture of solids, both of which are white, or more likely, based on this being the material that came out of a purification procedure at the end of this synthesis, it's a pure substance. Might be an element, might be a compound. It's likely to be a compound, given we ran a reaction to prepare it, but the most important thing to note here for now is it's a pure substance. Now, this liquid here on the right is qualitatively different from the liquid on the left in that it looks transparent. We can see through it to some degree. Yes, it's blue, but we can see through this, and everywhere we look, we have that same transparent appearance. It looks homogeneous. So this is a homogeneous mixture, also known as a solution. This turns out to be a solution of a copper-2 salt and water, I believe. And so it is a mixture of the copper-2 salt and water, but the copper-2 salt disperses itself, or really dissolves itself in the water, and distributes uniformly throughout the solution. And so this is a homogeneous mixture where the composition appears the same everywhere. Qualitatively different from this in that it's transparent. And this indicates that even at the very, very, very smallest level, we're going to see the same composition of this substance everywhere. We actually don't have to get down very far to see differences at various points in this heterogeneous mixture. Under a microscope, it would be very clear that there are solid grains and a liquid phase in this sort of translucent looking mixture.